Hey guys, this is Ms. Martinez, and in this video we are looking at special functions. Throughout this video you're going to be learning, and you will by the end be able to identify, evaluate, and graph constant, piecewise, greatest integer, and absolute value functions, and also be able to state the domain and range for all those types of functions. So let's get started with a definition. A function whose value is defined by different expressions for various intervals of its domain is called a piecewise function. And we're going to look at some examples of piecewise functions so that you can see where they get their name from. For this example, we're stating the domain and the range for this function. This function, looking at its domain, you're going to be scanning, and it's continuous. So look how far to the left and how far to the right does it go. Well, it looks like it gets started at -4 and goes all the way to 3, and it includes those values, so we have to put the equal to under our inequalities. For the range, you're scanning vertically. The lowest value we have is 2, and the highest value it goes to is 6. And we include both of those points because the circles there are closed in. For this graph, this is strange looking. This is an example of a piecewise function. They're called piecewise because, look, there's different pieces. So piecewise functions look like pieces put together, kind of like this on a graph. Okay, so our domain, this is kind of interesting. Look at the piece on the left in quadrant 2. It gets started at -6 for the domain, and it goes all the way to -1. But for this entire function, that's not all. It could be that, or it could be that other piece, which starts at 2 and goes to 4. 4 is not included, though. That's why there's an open circle. This would be the domain for this piece function. There are 2 pieces, so your domain includes one range or that other range. Now for the range, the y values, there's actually only 2 outputs. It's 2 for the piece in quadrant 1 and 4 for the piece in quadrant 2. Have another one like this. Here is another example of a piecewise function graph. The domain here, if you're scanning horizontally, the x's begin at -4 and they really go all the way to 5. Even though there's a break at 1, do you see the break as you're scanning? You're kind of like on a roller coaster. Woo! And then there's like this jump. But there at 1, it is defined. So that is all in our range. However, at 5, we don't include it because it's an open circle. And there's no closed circles filling in at 5. The range is going to be values beginning at -3 and going all the way up to 6. We have values between there for one or the other piece. All right, so that is example 1. If you turn your paper, we're going to look at example 2. We're going to actually graph a piece, or commonly called piecewise function. So this is the function. It looks kind of crazy. F of x equals -3 if your x values are between -5 and -2. The function f is x plus 1 if you're working with x values between -2 and 1. And your f function is negative x plus 4 if you're working with x values between 1 and 4. So we're going to have 3 pieces in this graph. We're going to begin graphing the first piece. The first piece right here is going to be occurring in that blue, kind of like inside of that blue rectangle on the graph. It's between negative 5 and negative 2. And that function, f of x equals, if you would, change that rule to be a positive 3 for me. Thank you. Okay, so this is just a horizontal graph, picking up at that height of 3 and also ending at that height of 3. It's just a horizontal line right through there. It's closed at negative 5 where x is negative 5, and it's open where x is negative 2. We determined that by looking at that inequality. That is the domain for that piece. So again, I accidentally wrote it as a negative 3 in the original function. It should be a positive 3. So if you'll erase that little negative symbol. Thank you. All right, now the next piece. The next piece is going to be occurring between negative 2 and 1. And the graph, the function there should be f of x equaling x plus 1. And lucky you, we've been working with these types of functions. They are just those linear functions, those basic lines. So for this kind of scenario, I really like to just pick those boundary points in the domain. So you're working with f at negative 2. You're looking at that green rectangle. That's where this piece should be picking up. So at negative 2, if you evaluate your function, negative 2 plus 1, that gives you negative 1. And we can plot that point. It's supposed to be a closed circle because at negative 2, we include that value for this piece of our function. And then we'll evaluate it at 1 because that is kind of like the end of our box that we're working in. And 1 plus 1 is 2. Now, this is an open circle because we are not including 1 in the domain of this piece. And we'll just connect those points because we're working with a linear equation here. All right, we have one more piece. The third piece is going to be occurring between 1 and 4. And we're going to use the same approach like we did in the last piece because it is, again, a linear function that we're graphing. It's f of x equals negative x plus 4. So we're going to pick that starting point in this piece's domain, which is 1, and plug it into our function. It'll give us 3. And we're including this point, so it is a closed circle. And we plot it. Positive 1, output of 3, closed circle there. And then we will evaluate our function at 4 because that is the end of this piece. And the value is 0. And it is a closed circle because we are including the x value of 4 in our domain. And we'll just connect those values. So there is our piece graph, our piecewise function graph. All the little pieces graphed according to their domain. Kind of cool. All right, now the last part here, we want to give our domain. Our domain is going to be from negative 5 to 4 for the entire graph. I know for the pieces it's different, but for this entire function, it is happening between negative 5 and 4. And our range is happening Well, the lowest point is going to be -1, and it goes all the way up to 3. All right, so there you've done it. You have graphed your very first piece function. Many to come. Okay, that was example 2. Now we're looking at example 3. Kind of the flip-flop here. We're going to write the equation given the graph. So first thing, we're going to figure out the domain for the first piece and the rule. So where is this happening? When you are between -4 and -2, that's the first piece there. Well, I know it's a line, but I don't know the equation of the line. What I do know is the slope. The slope, you go up 1 over 1, up 1 over 1. If you were kind of tracing, moving on that graph. And I know the point there on the x-axis is -4, 0. So I plug in the slope and I plug in the point into my point slope form. And then I will just kind of do some simplifying so that I can figure out the equation of this line. So y minus 0 is nothing. And if you're working with x minus a -4, that's really just x plus 4. And that all simplifies to y equals x plus 4. That is the equation of that little piece of the piece function there on the far left. Let's now look at that next piece. The next piece is happening when your x value is equal to -2 and then all the way up to 0. And that's a horizontal line going through 3, so that's just y equals 3. That one was pretty simple. We didn't have to do much to figure out the equation. Now this third piece, the last piece, it is happening when your x values are greater than 0 all the way up to 2 and including 2. And this is kind of nice. We can figure out the slope of this line by counting those the movement between those points. You would go down 1, 2, 3 and over 2. So our slope is going to be -3 over 2, and it's on the y-axis, so we know the intercept is at 3. So this one was pretty fast to figure out as well. Now with all of those rules and all of those domains, we can put it together to provide a nice function rule for this graph. The first piece, x plus 4, if x is between -4 and -2. 3, if x is between -2 and 0. And -3 halves x plus 3 if x is between 0 and 2. And I'm going to pause the series now. I'm going to end the video here, and there will be another video to kind of continue you with your last pages. Thanks. Stay tuned.